In this clip, we're going to learn how to calculate percentiles of a time series here or any data set in general. The data we are looking at here are monthly Northern Hemisphere temperature anomalies. We are starting with our observations in the year 1880 and in January, and that observation is in row 2. Now we want to find out where the last observation is, and that is available in September 2017, and it's row 1654. Now this sort of information is good to make our life easier. In fact, I've divided this time period into 4 periods: 1880 to 1950, 51 to 80, 81, 98, and 99 to 2017. I'll change that in a moment. Now, so here 2017, we already know the last observation is in 1654, and what you see in this table is just the first and the last observation in each of these quarters, and that's great information to have for what's coming. And sometimes a little bit of prep of that sort is very valuable, so we don't have to keep scrolling down the spreadsheet. So we use 51 to 1980 as our reference period, and we will use it to define what we consider a hot and a cold month. And we do it in the following way. For this reference period, we will want to find the 33rd and the 67th percentile. I'll tell you how we interpret that in just a moment. So 33rd will serve to define cold days, 67th percentile to define hot days. So let's first calculate this value. We'll use the percentile command, and in particular, it doesn't matter which of the 2 percentile commands we use. Really, if you have so many data, we need an array, a data array, and a percentile. So now for this period, we know where the data are. The data are in column C, and for this reference period, from row 854 to row 1213. So instead of, you could highlight this period with your mouse, but here it's quicker to actually type C854 to C1213, and now comma. And now the question is which percentile. We want the 33rd, and the way how you do that is to say 0.33, close parenthesis and enter, and here's your observation. So what's that number mean? Negative 0.0887. That means for that reference period, a third of observations is smaller than that reference number. So a third of the monthly temperature anomalies are smaller than negative 0.0087. Now we want the 67th percentile. We'll start by just copying this across. Now the reference period has moved by 1 row by copying this down. Since we only do this once, I'm just manually changing this reference period back to the 854 to 1213 row. Otherwise we could have used dollars, but now instead of 0.33, we use 0.67 to get the 67th percentile. So 67% of observations of monthly temperature anomalies in our reference period are smaller than 0.08. That means a third of observations are larger than that value, and that's what we will define as hot days. Now this is a very unique definition of hot and cold. That's the one we use here. You may think of other definitions. What we now want to figure out is, in the 4 periods, the number of hot and cold days, do they increase or decrease? If you know a little bit about global temperatures, you know what happens. The number of hot days increases. But let's see how we do that. So we want to calculate the frequency of cold and hot days for each of these 4 periods, but then we will also calculate a percentage of cold and hot days, so we can it's easier to compare the periods. So what we want in this cell is the number of observations in the period 1880 to 1950, monthly observations, that is smaller than negative 0.0887. And that will give us the number of days defined as cold in that subperiod. And we are using a command called countif. And there are two inputs, a range of data and a criterion. And the command counts the number of observations in that range that meets that criterion. So the range is easy. We know where our data are. Then column C, and for this subperiod in rows 2 to 853. Now what's the criterion? The easiest way, since we only have these two numbers, we'll just sort of enter it manually. You have to put it in inverted commas. Don't ask me why. That's just the way it is. So in inverted commas, and here we say smaller than negative 0.0887. Okay, so please count all the observations that are smaller than that, and it turns out it's 578 months. It's about 70 years of data, 72 years of data, and 578 months are considered cold according to our definition, which is based on the 51 to 80 reference period. What about hot days? So we say countif, the same data range, C2 to C1213, C2 to C853, and the criterion now is the temperature normally larger than 0.08. And indeed, it is in 131 months. So what we now do is we just copy these cells down because the criteria are exactly the same, but we now have to go to these three other subperiods and change the data references. So let me do that here. So here the data are in C854, so that criterion stays the same, okay, but the data are now in C854 2, meaning colon C1213. So, and we equally have to change the reference period here, C854 to C1213. And let me change the references for the other two subperiods as well. So here I'm changing it for the last one, for the hot days, for the 1999-2017 period. So, and what we now have in these cells are the frequency counts of hot and cold days in these four periods. Now, since the periods have different lengths, they're somewhat difficult to compare, although some patterns you can possibly already tell. What we now want to do is we want to calculate percentages. How do we do that? We take number of cold days, we divide by the number of days in a period. So we take the last observation minus the first observation, but we have to add one because we sort of subtracted the first observation as well. Before we press enter, we shall also fix some references here, in particular the columns for which we use to calculate the number of observations in our quarter, because as we copy this cell to the right, we don't want the columns to change. So we fix the columns by putting a dollar in front of the column indicator, the H and the G respectively. So 68% of observations were cold and 15 were hot. 15% of months in between 1880 and 1950 were hot. If in your case the data aren't shown as percentages, highlight them, go to Format Cells and click on Percentage, for instance as here with 0 decimal places. Now we just need to copy this down. Let's click in the formula to see that it actually calculates the right thing. Number of hot days divided by the number of days in this period 51 to 80. That's exactly what we want. So that's the right formula. Putting the dollar signs in has done the right thing. It's always worth checking though. Now it's not a surprise that in the reference period we have 33% cold and 33% hot days, because that was exactly how we defined hot and cold initially. So we can clearly see that as we move on in time, the months are getting hotter. In fact, in the last period, 1999 to 2017, according to our definition, we only have hot days.